Hello, welcome student. In the previous lectures, we are finished the topic number 13, electromagnetic waves and communication system. In these lectures, we are start the new topic and topic number 14, the last topic of your syllabus, 11th standard physics. The topic number 14, that is the name of that topic is semiconductor. In the previous years, we are discussed only definition and meaning of that word, the semiconductor. The semiconductor, it comes up in between the insulator and conductors. In the previous lectures, we are set definitions of the semiconductor. It is the metal, the material. It is not a metal, a material which can be acts as a perfect insulator in 0 degree Kelvin temperature. If the improving of the temperature, the conductivity of that material is increases, and this material is called as semiconductors. In these lectures, we are seeing the semiconductor, informations of the semiconductor, introductions of the semiconductor, and what is the exactly happened, what is the process is happened inside the semiconductor when we are improving the temperatures. The most important part of the semiconductor in the electronic physics is happen. The most important things in the electronic physics is the semiconductor, because all gadgets, the gadgets we are seeing, a lot of gadgets, that is cell phone, smartwatch, LED, televisions, and a lot of things, lot of electronic things that comes up by the making of semiconductor. Semiconductor पासूनच त्या गोष्टी तयार होत असतात. त्यामुळे semiconductor, it is a most important topic, it is most important subject, it is most important part of the physics, and it is most not only important for the 11th standard physics or 12th standard physics, it is most important to the whole life. And let's start to begin the journey of semiconductors. In these lectures, we are discussions of the introduction of same, that is semiconductor. Introductions of semiconductor. In the previous years, we will be seeing the definition of semiconductor is, the definition of semiconductor is a devices, it is not a devices, a material, it is act as a perfect insulator, perfect insulator in 0 degree Kelvin temperature, in 0 degree Kelvin temperature. If temperature increases, the conductivity of that material, the conductivity of that material the conductivity of that material is increases is called semiconductor. You will be can't write the different word as a semi and conductor. Combine the both words and write semiconductor. Call semiconductor. एक असा डिव्हाइसेस आहे, जेव्हा 0 डिग्री केल्विन टेम्परेचर त्याला दिलं जातं तर ते परफेक्ट इन्सुलेटर और बॅड कंडक्टर म्हणून काम करतं. जेव्हा टेम्परेचर इन्क्रीज करत जाल, टेम्परेचर वाढत गेल्यानंतर इट इज कंडक्टिव्हिटी ऑफ दॅट मटेरियल, यस हियर कंडक्टिव्हिटी ऑफ दॅट मटेरियल विल बी increases. This material is called as semiconductor. But अशा पद्धतीने काहीतरी भानगड एडपट भानगड यामध्ये होत असतं. एक्झॅक्टली होतं काय या सेमीकंडक्टरमध्ये आपण आता बघूयात. दिस इज द नॉट युअर पार्ट, इट इज नॉट अ पार्ट ऑफ युअर सिलेबस, फॉर जस्ट इन्फॉर्मेशन्स अबाउट द सेमीकंडक्टर वी आर सीन हियर. द फंक्शन इनसाइड द सेमीकंडक्टर. Consider or seen, this is the conduction band inside the semiconductor, and this is another one is valence band. Conduction band and valence band, and in between the both band, this is the gap, this is the large gap, this is called as forbidden band or band gap. This is called forbidden band. This is the, I will be again say, this is not a part of your syllabus. Just revise the definitions of the semiconductor. It is acts as a perfect, it is a material which can be act as a perfect insulator in a 0 degree Kelvin temperature. If the temperature will be increases, the conductivity of that material is also increases, and this material is called as a semiconductor. Okay, let's see. This is all will be, this is the semiconductor. In the inside the semiconductor, this is conduction band, this is the valence band, in the between then forbidden band. The electrons will be present in the conduction band that takes part in the conductions of electricity and heat. जे इलेक्ट्रॉन्स कंडक्शन बँड मध्ये असतात तेच इलेक्ट्रॉन्स कंडक्टिव्हिटी मध्ये भाग घेत असतात. ते हीट कंडक्टिव्हिटी असू दे किंवा इलेक्ट्रिसिटीची कंडक्टिव्हिटी असू दे. व्हॅलेन्स बँड मध्ये असलेला कुठलाही इलेक्ट्रॉन्स कंडक्टिव्हिटी घडवून आणत नाहीये. Okay, let's see what is in a conduction band. Conduction band are partially filled by electrons. Partially filled by electrons or completely empty. Completely empty, but can't completely filled. Fulfilled. ओके, जे कंडक्शन बँड आहे हे कंडक्शन बँड पार्शियली म्हणजे थोडा फार इलेक्ट्रॉन्स त्यामध्ये इलेक्ट्रॉन्सनं भरलेलं असतं किंवा पूर्णपणे रिकाम असतो, कम्प्लिटली एम्प्टी, पण पूर्णपणे कधी भरलेला नसतो. इट इज ऑल अबाउट द कंडक्शन बँड. And I will be seeing the valence band is different. The valence band may be completely filled by the electrons or partially filled by the electrons, but it could not be completely empty by the electrons. Then what is exactly happen if we are increasing the temperature? जर आपण टेम्परेचर वाढवलं तर सेमीकंडक्टरची कंडक्टिव्हिटी कशी वाढते हे आपण बघायचं आहे. मी याच्या अगोदरचे लेक्चर स्टार्ट केल्यानंतर म्हटलेलं जे इलेक्ट्रॉन्स कंडक्शन बँडमध्ये असतात तेच इलेक्ट्रॉन्स कंडक्टिव्हिटी घडवून आणतात. ते हीट कंडक्टिव्हिटी असू दे किंवा कंडक्टिव्हिटी ऑफ इलेक्ट्रिसिटी असू दे. ठीक आहे. देन द इलेक्ट्रॉन्स विल बी सम इलेक्ट्रॉन्स इज प्रेझेंट इन हिअर. प्रॉपर 0 केल्विन टेम्परेचर, 0 डिग्री केल्विन टेम्परेचर जेव्हा असतं तेव्हा कंप्लीट कंडक्शन बँड इज कम्प्लिटली एम्प्टी असतं. इफ वी आर इन्क्रीजिंग द टेम्परेचर, आपण टेम्परेचर वाढवत आहे असं कन्सिडर करू. लेट्स वी बी सीन वन ऑफ द ग्राफ temperature versus conductivity. This is the conductivity. I will write sigma, and this is on x-axis. I will take the temperature. If we are the increases the temperature, conductivity is also increases, and graph is a linear straight line graph. The linear relation between the conductivity and temperature in the form of semiconductors. Let's see what happened when we are increasing the temperatures. The temperature will be increases, the electrons will be present inside the valence band. जे काही इलेक्ट्रॉन्स आहेत व्हॅलेन्स बँडमध्ये असतात, the electrons will be get excited. The electrons inside the valence band they get excited and move towards to the conduction band. आणि हे इलेक्ट्रॉन्स कंडक्शन बँडकडे ट्रॅव्हल करत असतात. They move towards to the conduction band. आफ्टर द इंक्रीजिंग द टेम्परेचर, थोडासा टेम्परेचर जेव्हा वाढतो, स्लाइटली इंक्रीज द टेम्परेचर वाढलं तर ह्या बॉटमच्या जागी असलेले जे काही इलेक्ट्रॉन्स आहेत इन द व्हॅलेन्स बँड दे मूव्ज अप टॉप ऑफ द व्हॅलेन्स बँड. ते बॉटम खालच्या भागेला असलेले इलेक्ट्रॉन्स हे वरच्या भागेत जातात आणि त्यापेक्षा जर टेम्परेचर वाढवत गेला तर ते एक्साइटेड होत असतात. दे विल बी एक्साइटेड अँड मूव्ज ॲट द बॉटम अँड रीच ॲट द बॉटम ऑफ कंडक्शन बँड. कंडक्शन बँडच्या खालच्या भागात जाऊन पोहोचत असतात. इथून इलेक्ट्रॉन जर इथं गेला, इथून इलेक्ट्रॉन इथं गेला तर ही जागा रिकामी होते आणि इन दिस एम्प्टी स्पेस द मेक्स होल्स, त्या ठिकाणी होल्स प्रोड्यूस होत असतात. जसजसे टेम्परेचर वाढत जाईल तसतसे हे इथून टॉपवरून जाऊन बॉटमवर त्या बॉटम ऑफ द कंडक्शन बँडमध्ये पोहोचत असतात. अँड द इलेक्ट्रॉन्स कम्स इन द कंडक्शन बँड दे टेक्स अ पार्ट ऑफ द कंडक्टिव्हिटी, आणि हे इलेक्ट्रॉन्स कंडक्टिव्हिटी घडून आणत असतात. तर ह्या फॉर्बिडन बँड हा डिफरन्स जर कमी करायचा असेल तर या ठिकाणी होल्स तयार होत असतात. And these holes and these electrons start gets attracted to each other because the unlike charges will be attracted. We are discussed in the magnetism as well as electrostatic topics. The unlike charges will be attract to each other, आणि हे दोन्ही अनलाइक चार्जेस आहेत ते अट्रॅक्ट होत असतात, आणि अट्रॅक्ट झाले तरी हा फॉरबिडन बँड हो रिड्यूस होत असतो, मिनिमाइज होत जातो. देन इफ इंक्रीजिंग, स्लाइटली इंक्रीजिंग, again and again increasing the temperature, the electrons will be gets excited again and again, reach in the conduction band. The conduction band electrons as a free electrons or mobile electrons, they takes part in the conductivities. This is all about the semiconductor device, the semiconductor functions. This is not a part of your syllabus, but just information what is exactly happened inside the semiconductor. Okay, let's see the conductivity of the different properties, or the conductivity of the different materials. Consider the conductivity of the metal, consider the conductivity of the good conductor, consider the conductivity of the good insulator, and conductivity of the good semiconductor. The conductivity of the good conductor is a silver is a good conductor. Then the conductivity of that silver is 6.25 into 10 raised to 7 Simon per meter. This is the conductivity, highest conductivity of that materials. या 6.25 into 10 raised to 7 पेक्षा जास्त conductivity कुठल्याही मटेरियलचा नसतो. This is the highest conductivity because this is the good conductor. Silver is a good conductor which having the highest conductivity. Then a bad conductor and a good insulator's conductivity. The good insulator is a glass. Glass is a good insulator. Then conductivity of the glass is a 10 raised to minus 10 Simon per meter. And this is a less quantity, this is a less amount of conductivity. ह्याच्यापेक्षा लेस व्हॅल्यू आहे आणि ह्याच्यापेक्षा कमी व्हॅल्यू कुठल्याही कंडक्टिव्हिटीचा नसतो, कुठल्याही मटेरियलचा कंडक्टिव्हिटी ह्याच्यापेक्षा कमी नसणार आहे. देन द लास्ट वन इज the best semiconductor devices. The best semiconductor devices is silicon. The best semiconductor devices is silicon. The conductivity of that silicon is semiconductor is 1.5 into 10 raised to minus 3 Simon per meter. This is the all about conductivity of the different parts. There's the conductivity of a good conductor, conductivity of the good insulator, and conductivity of the good semiconductor. ह्याच्यापेक्षा जास्त कंडक्टिव्हिटी कुठल्याही सेमीकंडक्टरचा नसतो, ह्याच्यापेक्षा जास्त ह्याच्यापेक्षा कमी कंडक्टिव्हिटी कुठल्याही इन्सुलेटरचा नसतो, तर ह्याच्यापेक्षा जास्त कंडक्टिव्हिटी कुठल्याही मेटलचा नसतो. द हाय व्हॅल्यू ऑफ द कंडक्टिव्हिटी, दिस इज रिमेंबर फॉर द MCQ. द हाय व्हॅल्यू ऑफ द कंडक्टिव्हिटी ऑफ दॅट मटेरियल, गिव द नेम ऑफ दॅट मटेरियल्स अँड द व्हॅल्यू ऑफ कंडक्टिव्हिटी. द नेम ऑफ दॅट मटेरियल्स विच हॅविंग द हाय व्हॅल्यू ऑफ कंडक्टिव्हिटी, that is the silver, and the value of the conductivity of that material is 6.25 into 10 raised to 7 Simon per meter. You will be please remember for the units of conductivity. जर युनिट्स लिहायला विसरला तर किती मार्काचा क्वेश्चन आहे त्यातला हाफ मार्क मे बी कट होऊ शकतो. Gives the less value of conductivity and give the name of that material. The material acts as a good insulator as a glass, and the conductivity of the glass is 10 raised to minus 10 Simon per meter. Then this is all about the semiconductor. Just again revise the definition of semiconductor. This is only part of your syllabus. This is not a part of your syllabus. This is also the part of your syllabus. This is all three things will remember for the MCQ, most important things for MCQ, and most loved example, loved questions of our examiners. Semiconductor, it is act as a perfect insulator in the 0 degree Kelvin temperature. When the temperature will be improved or increased, if the temperature is increased, the conductivity of that particular material is increased, and that conductivity of or that material is called as a semiconductor. This is the definitions and introductions of the semiconductor. In the next lectures, we have started discussions of the semiconductor which are taking the part in your syllabus. Okay, we are stop here.